Okay, this is the second live session I discuss about this part, and so I'm gonna go very fast just for the other student that didn't listen this. It's gonna be very short, not 5 to 10 pages. It's let me change this. It's gonna be 46 maximum page. Um, Very short, no need for the intro and for the literature review. Very short introduction, go with the meta section, discuss your hypothesis, the data set, the variable methodology, software, and then go with a report of descriptive analysis, the distribution of your data, test the hypothesis, write a result section, discuss the finding, and then policy recommendation. You are welcome to have a abstract. This was a very short review of the class, of the presentation till now for the class that they did not participate here. Okay, let's go with an example here. Um, for the example, for example, you consider you are going to work as a with the Medicare National Data by County, and I should change the first section here. The question was, is there any racial disparities between black and white who receive eye exam? This is the question, and then okay here, and the topic should be comparing average percentage of female, or not even female, percent of Medicare enrollees who has at least um, one one eye exam, or just an eye exam. So the topic for this data set is which topic class? You know that by now that the topic for this data set is Medicare National Data by County. This data set provides us the percentage of utilization of service for the Medicare enrollees, and then this data set is available in CSV file, so you don't need to convert that to the CSV. Anyhow, if you are going to work on the, some of the students are not following the class instructions, so they have lots of problem with reading the data sets. All of the data sets you need for the individual assignment 2 are already converted to the CSV file, so you don't need to convert them. But anyhow, if you decided to work more with the data, I like to work with the Excel file, so you need to convert that to the CSV file, and then it's going to be easy to read. It is possible to read the Excel file by RStudio, but if you want to change that, you need to rewrite the codes. I do not recommend you to just go with the Excel file because you need to change all the name of variables. Okay, it was I only discussed about that, so please try to use the CSV file and you're gonna be fine. Oh, first of all, you need to see the name of dataset, name of variables in the dataset. For the example I'm just presenting here, you need two variables here, and you know this is the command name for the name of data. This is the way, you know, I read this dataset here and I call this dataset data. If you call it any other name, this is fine. You can call it any name you like. But whenever you are using the name command, you need to put the label you used here. So by default, the label is a data. So here is a data, and here I'm looking at this data set. I see I have two variables here, percent of eye exam for black and percent of eye exam for white population. These are the two variables I need, and then I need to use the mean function. The mean function use the data set $sign name of variable na.remove equal true. It does mean if there is a missing in the data set, remove that missing and then report the result. So this is the first one is eye exam for black, the second one is eye exam for white. And then I'm gonna go with the same standard deviation using the SD function. The SD function uses exactly the mean function and then just report the result. It's easy to go with this. For number of observation, you need to go with the my table command. The my table command, this is the first part. My table, this side, table, data, dollar sign, name of the variables you want to use, and then summary my table. And you can see the number of observation here. The same for the, this is for share, yes, data, CSV file. Mhm. No, no, no. This is the command. You are not generalizing anything. This is the command. Yes, this is the command. Yes, this is the command you need to generate. And this command only give you one number. I will show you in the RStudio later. Stay with me. Yeah, give me 5 minutes. I will be in the position to to show you the result for this command. And then, okay, this is the my table command. Then you have a t-test command. The t-test command is a t-test, name of data set, name of variable, the first variable, name of second variables. And then you need to use an a.remove equal to true. So by default, the RStudio gives you unequal t-test. So the result should be Welch sample t-test. Welch sample t-test here, as you know, the t-test commands give you different variables, different values. The only thing you need here is this one, the p-value here. The p-value, if the p-value is less than 0.05, less than 5 percentage, there is a significant difference between your data set. For example, here, look at the black. Here I exam 62 percentage, white 66 percentage. These two numbers are very close to each other, but because the standard deviation is very small, so they are significant. The white population more likely to use more eye exam than black population in the US, not in any country, because this data set, this analysis is for the US. So this is the point for t-test. And then you need to visualize your data. This is the standard codes for any data set you want to use. You only need to change this variables here, percent of eye exam, percent of eye exam white, the figure, and this variable. These are the part you can change with your data. If you are, for example, using with hemoglobin A1C, you can change that, and you are going to compare the hemoglobin A1C between black and white population, or you are going to see the percentage of diabetics, because the hemoglobin A1C is for measuring that. And then you can just change this to this one. This is the name of data set, right? Hemoglobin A1C we have in some place here, hemoglobin here. Overall and hemoglobin, we have hemoglobin probably for black and white. Where is, oh, here, hemoglobin black, hemoglobin white. So you can just change with that, these two variables. I think at least one of the students using this percentage of diabetes. Okay, and then you will have the box plot, and you know how to read the box plot. Most of you are doing it for the exercise. You are good with this section. Okay, I expected to have, I have 8 more minutes, but if it's disconnected, I can start the next section. And then you can just go ahead with a density plot. For the density plot, this is the master code. The only place you need to change the highlighted one here. And it doesn't matter how you call them, but if you change this MDVA, it was, you need to change these two here. So also don't change them, just change the highlighted one, and you are able to see the density plot. So for this assignment, I expected you use the 6 function. The first function, I don't call it reading the data set as a function, but that's a function. I need you to now understand the mean function, the standard deviation function, the t-test function, my table function, box plot function, and density plot. 6 function. So this assignment is just to just to show how do you learn this in the class. So I repeat that: mean function, a standard deviation function, t-test function, my table function, box plot function, density plot function, 6 function. Let me go to the RStudio and then show you how to use that. This is the example I used for the presentation. Can you see my screen, correct? Okay, this is the data set. First of all, I need to read this data. I see data read.csv. This is the location of file in your computer, and by default you are putting all the file in CUMUC. If you are using the MacBook, it's gonna be tilde documents slash UMUC. Oh, depends on the location of your computer. So I know for sure, I expect that all of you know how to read the data from the computer. Okay, this is the data set. I'm looking at the name of data sets. Okay, I can see in some point I believe I opened the sync command. I need to close this to see. If you are not able to see any command, any output in your console here, this is the console, right? And you can see only the blue line here. More likely you open the sync command and you didn't close the comment. So I'm gonna close this in my computer. I'm gonna read one more time, and in this time I expected to see output. Okay, here I expect to see output in my console. I can see that, and then I'm gonna go with the mean function. The mean function has a mean, name of data, $, name of the variable, and na.remove to remove the missing part. So you can select both of them. So here I can see this is the mean, this is the mean for black here, this is the mean for white, and then I have a standard deviation, and the standard deviation shows how the data, how there is is there any wide differences between two variables. It's almost wide. Here is more than 10% of variance. The 10% variance is 6, right? Because we have 62 multiply 10 is going to be 6. Whenever I have 8, I have almost 12% variance. So I expected in some place I have about, if I was in a position to see each single variables, I expected to see maybe 45 plus 16 plus 12, it's going to be 67, and maybe 45. So this is the how data distributed. It's and then this is the question you ask for me. This is the my table command. The my table command just give you this number here, n, number of observation. You need this number to populate the table. I will show the table later here. And then you need to go for the my table command for, okay, I have to change it to iExam here, right? This is the iExam for the white. And this is the my table. I can see the result here. Okay, 2100. And then I'm gonna go and check the t-test. This is the t-test. The p-value is less than 0.05. There is significant difference between them. And these three lines, always select all lines related to the box plot together. Otherwise you are not able to see any plot here. And then run this, and you can see there, you can see slightly white is higher here. So for that reason the p-value is significant here. And then you can see the density plot. Select all of them together, and you can see the density plot. The B is a black and the white is white, is a white. The blue is white, so you can see the white is a little bit higher than the black. So this shows the data is normal distributed here. There is no outliers in data in this data set, and you know how to switch between two plots. You can press here, right? Press here to switch, and you can always export the data, copy to the clipboard, copy and paste in the Word document. This is the draft. Can you see my screen? Okay. If you like to go with exactly this draft, this is completely fine. You can use this, modify the word, change the word based on your topic, and go with this instruction. It's completely fine with me in my class. And I believe Dr. Aziz doesn't have any problem. Dr. Aziz, is it okay with your class for your student to use exactly the same platform for your class? Okay. Okay, Dr. Aziz approves that approves that you can either use this platform, this draft. This draft is a start with introduction, a short introduction, a method section, hypothesis, datasets, material and method, variable. Here, this is the variable's name. You need to define the variable. For example, here in my example, the variable is um, eye exam black, eye exam white, right? The variables is the definition of the variable is it the percentage of black population using eye exam and the percentage of white population using eye exam. And description of the code is numeric data set. Both of them is numeric for the example I provide. The source of data set is Medicare national data by county, and the year of the data, I believe the year of data is 2012. And the method you are using descriptive analysis. The only test you are using here is a t-test, so you need to discuss about the method section. You can say I'm using a descriptive analysis and I'm using the t-test, and please add at least one citation for t-test. And there is a, I believe in week 2 or 3 I provided a well sample 2 t-test. You can use that, or you can use any other source to support what the t-test is. And for the data analysis process, you can easily discuss what I say here. You can say, okay, I read the data set, I look at the variables, I use the t-test, and then I use the RStudio for that. It's going to be very simple as you are doing, so you can just write in a few lines and then discuss your results. In the results, first of all, report with the numbers. Say, okay, there is, for example, how much was here? There are 300 black population, 2100 white population participated in the data set. The mean average for the black is 62.5, right? I'm just what happened? Okay, what happened? Gillette, can you mute your computer, please? Okay, that's perfect. And then, okay, discuss the mean and discuss the standard deviation, and then you can also cite the plot you're using. For example, you can say as reported in the Boxplot here, this is the distribution of the data, and then report the findings in the table like this. You're gonna have two variables here, black, white. Number of observation, you have already the number, you have the mean, you have the standard deviation, and you have the p-value. For the p-value, it's usually you don't need to report more than 4 decimals, but this is completely fine if you like to copy exactly the number reported here. This number is 2.2 e on power of minus 16, so it's very small number, is very almost 0, so it's 0, 0, 0 is fine. And then we discussed the t-test. Say, okay, why do you how do you understand the t-test? Is it significant different? What does it mean that is significant different? And what's the level of significance? Here by default the level of significance is 5%. And then you can discuss your find the means in the box plot and report the box plot here. For the discussion is about what you are thinking about your results. For example, you can say something like, if you are choosing the Medicare national data by county and you are comparing the black and white population, you can say something about the disparities in health. Say, okay, there's a disparities between black and white population, and as I see here, if you are working the Minnesota data, you're gonna compare, for example, most of you are using the admission rates or add number of admission. You can say, okay, the number of admission is, for example, for the medical, the surgery is higher than, for example, pneumonia, and the reason is, for example, maybe there is more pneumonia in the population, or there are more people more likely to report to go to the hospital for the heart disease more than pneumonia, something like this. I mean, the way you are thinking, it should be scientific way to report your finding. This is a discussion, this is the place for you. You want to discuss your finding. And then okay, the limitation of the data, the limitation of your data is not more than 2 or 3 lines. So this is example for the class. You are working on a two population, you did not run regression model, so there's some kind of limitation. I report most of them here, so you may like to modify the limitation. The conclusion is exactly like a wide abstract. 4 different sections: 2 or 3 line introduction, method section, your findings, and your conclusion. Final conclusion gonna be, for example, there is a significant difference between black and white population here, and one policy recommendation here. This is what I expected to see for this. And then make sure to just work, report all the references you work, make sure to work APA style, because the AP is a 10% of your grade. So if you are doing the great job but you are not in APA style, I have no choice, because there is a place for APA. So if the paper is not in form of APA, I'm not able to give you grades. So it's very easy to go. If you are using this draft, this is fine. It's already in the APA format. Okay, this was very short review on the I exam. Any question here? So I have, probably it's going to be a stop in a minute. I believe I posted in the class. Yep. Sure, you're welcome. Probably it's going to be a yes. If you can use this format, or you can go with your APA default. This is up to you. As long as you are following the APA, this is fine. Yes. You consider someone, because the UM used to have a different policy. If some other person look at the file and see it's not APA, and I'm not there to defend. Okay, it was my suggestion. So we have some standard. I need to go with the standard. You need to go with that standard. Sure, you're welcome. So fortunately, we are still on. If something happen, I will back. Any questions so far? No question. If you don't have any question, I can review another. All of you are using the Medicare data set. Who is? Oh, what's your topic, Andrea? Okay, you are using the Minnesota data imaging data set. I have an example for that. You say between CT and MRI. Okay, my next example is exactly about CT and MRI, so you can watch that carefully. So you can, it's gonna be so helpful. Okay, okay, I'm gonna go with a Minnesota imaging data set. I'm going to compare the CT and MRI here. So it's exactly for Android and any other student they are using this. And this is extra credit, isn't it? So I think Andrea like to give me extra credit, right? Okay, Andrea, this is a data set. Make sure to use this data set, Minnesota imaging process 2000. I'm not reading that. So whenever you are reading this data set, and then make sure that look at the name of data sets, and this there are two variables here. You need to compare memory procedure and CT procedure here, and then you can use the mean function to see the n here, your mean. Okay, this is the problem with this. It should be MRI procedure. Okay, this is the MRI, and this is the MRI. Okay, let's see the means. Here is the means for, okay, the means for CT is this one, the means for MRI this one, 2048, and you have the standard deviation for the same data set. And then you're gonna go with the my table command to see the number of observation. You have this 228 for the CT, and you have 299 for MRI. And then you're gonna go and compare the t-test to see the result. The result is significantly different because the p-value is less than 0.05. And then you can look at the box plot here. There is, I can say there is a outliers here. You may like to remove the outliers here. This command remove of the outliers more than 20,000, so I'm gonna remove them, and I'm gonna run the box plot without outliers. Much nicer picture. You can see that this is without outliers, and then and this the label should be number of procedure. Make sure to just I will send this to Dr. Azir to post in the class. If you're using the data set, the codes, please make sure to use the updated codes. We need to have a few modification for that. And then this is the density plot. This is a CTMRI, and this is it. So Andrea and any other student you are using this, so you already have all the results here. You can compare your result with this. It was, yeah, it is really short. There's only 6 function. Yes. Okay. Sure, you're welcome. I also can use another example using we used Medicare National Data by County. We used eye exam, and we can use, okay, we can use another data set from the Minnesota data. Let me open one of the Minnesota data. For some reason my Zoom session did not disconnect. I'm happy. I don't know what's happening here, but it's good. um, yeah, I like to say that, but I'm hesitated to disconnect just now. I can say that, so I'm holding that, and I will let, so just in case something happened, I don't like to do any judgment for that. Okay. Okay. This is, let me see, Minnesota. Okay, this is here. Let's see what's this. Okay, this is the Minnesota data for the hospital, and then this is the big data set. You can see there are lots of variables here, and for this example I'm going to compare the nursery admission with nursery admission at birth. So this is two data sets, these two variables. So you know the point is here, you just need to look at the variable you are looking to see. Where was that? What happened to this? I missed. Okay, here. And I'm looking the min. Okay, here when I look at this, I just need to see the name of data set. I like to see the example was the nursery admission and bursary admission. The nursery admission is someplace here. Bursary admission is here. This is the bursary admission. I just need to change that, and the nursery admission here, this is here. So you can you just need to change the name here, and then you can go with the mean function, see the mean. You can go with the standard deviation function and see the standard deviation, and then you can go with the my table command and see the number of observation here, 98, 97. You can go with the t-test. Is exactly that, it's significant different. 0.001 is less than 0.05, and then you can go with the box plot to see if there are any outlier here. Probably yes, probably no. I don't consider these are outliers. These are two. Probably if you look at the standard deviation, you can see the size of differences. Look at the standard deviation here. What happened? At some point I'm okay here. The standard deviation is almost 1,000. So for that reason, let me give you one more time the box plot here. The standard deviation is 995 here, right? So 3,000 till 4,000 is 1,000. So 1,000, 4,000 till 5,000 is 1,000. So I don't consider this as an outlier. By default, if you have more than twice of the standard deviation, you can call it outliers. So you can look at something like that. And then you can go with the density plot here. This is the density plot. And these are the bigger hospital, but this is fine. So this is for the Minnesota data. I'm reviewing all this session. I reviewed the Medicare national data by county. I reviewed the imaging data just for Andrea and other students. And then I reviewed the Minnesota data, and then if you follow this video, I think it's very easy to go, and please start your assignment very early, so don't postpone to the last minute. So if something happen, who knows, so something happened in the very last day and you are not able to do that, and this is really important. Almost 20%, 60 till 20% of your grades. I think it's 14% of your grade in the very assignment too. So I'm finished with my presentation. If you have any question, I'm here to answer your question. No? No, Sophie, no answer, no question for you? Okay. Okay, thank you very much, class, for being here, and happy Easter again to all of you. And if you are watching this video, please watch it very carefully, and you can just, but please start your assignment as soon as possible. Don't postpone this. Same to you. Thank you. Thank you so much. You're welcome. Thank you. Have a great day. You're welcome, and thank you very much, Dr. Azad. Goodbye. Okay, I'm gonna stop here. Oh, this is the end of presentation. Thank you. Goodbye.